This is Module 4, Lesson 23. We're just going to do a little bit on this one. I only have a few places where you might use this in our work. What we're going to do is we're now going to find solutions, if they exist, using substitution that requires isolation. Now, what do I mean by isolation? Start right here. We have done this. We have found the solution for a system of equations, because we know a solution for a system of equations is the point where the two of them intersect. So it's going to be a set of coordinates. You need the x and the y. What we've had before is we've had at least one equation that said y is equal to or x is equal to, but these don't. What I can do is I can take one of these, either one of these, and solve for y or x. I'm going to solve for y on this one. Negative 3x plus y equals 8. All I have to do is add 3x to both sides to move it on the other side of this equal sign. And I now have y is equal to 3x plus 8. Okay? So instead of using this equation, I've got y is equal to 3x plus 8. Now, as I have done in the past, if I'm solving for y, if I'm trying to get y or x, the first one I'm usually trying to get is x. I'm going to try to go after x. Okay. I take this equation here, and wherever y is, I'm going to plug this in, 3x plus 8. I'm going to plug that in for y. So I've got 8x minus 3 times 3x plus 8. Okay? That's what y was equal to when I solved for it. That's equal to what? Negative 19. Plugged it in. 8x minus 3 times whatever this y was equals negative 18. Now, PEMDAS tells me that I need to do the parentheses first. 8x, negative 3 times 3x is negative 9x. Negative 3 times 8 is negative 24. That's equal to negative 19. Before we cross the equal sign, let's collect like terms. 8x minus 9x is negative 1x. 1x minus 24 equals negative 19. Let's add 24 to both sides. Negative x is equal to 5. I don't want negative x. It's the same as negative 1x. I want positive x. So let's divide both sides by negative 1. And my x is equal to negative 5. So the x is negative 5. How do I find the y? I plug it into my equation here. If I'm looking for the y, I've got y is equal to 3x plus 8. So let's plug this in. If my x is negative 5, y is equal to 3 times negative 5 plus 8. Y is equal to negative 15 plus 8. So y would be equal to negative 7. My coordinates are negative 5, negative 7. And let's do one more. I promise you guys, these are not really going to be on my testing. I just want to make sure you see them in case you run across them somewhere else. I've got two equations, but neither one of them say x is equal to or y is equal to. This one here looks like it'd be pretty easy to solve for y. So let's solve it for y. Let's change it so it says y is equal to. I can subtract 4x from each side, and I get y is equal to negative 4x plus 1, okay? So instead of this equation, I'm going to have y is equal to negative 4x plus 1. Now, to find x, because remember we're looking for where these two lines intersect, we're looking for the xy value here, this point. To find x, let's substitute our y for negative 4x plus 1 in here. I'd have negative x minus 2 times negative 4x plus 1 equals negative 16. negative x, and this negative 2 times negative 4x is positive 8x. Negative 2 times 1 is negative 2. Negative x plus 8x is 7x. So we're collecting like terms. 7x minus 2 equals negative 16. Let's add 2 to both sides. 7x is equal to negative 14. Divide both sides by 7, and x is negative 2. Okay, so my x coordinate is negative 2. How do I find my y? I'd plug it into either one of these equations. Look, I've got it already solved here. So let's find our y this way. Our y is equal to negative 4x plus 1. See, that's how I solve for it. Let's plug in our x. Y is equal to negative 4 times our negative 2 plus 1. Negative 4 times negative 2 is 8 plus 1. Y would be equal to, what, 8 plus 1, which is 9. Did I get all the positives and negatives right here? Negative 4, that's 7. Yeah, I think I did. Negative 2, 9. Okay? Simple enough? All right, we're going to stop there because we're not going to use this part of it very much.